Spencer Deame. I'm a marketing manager at Nextera Video. We are a technology provider. We help equipment manufacturers add NMOS and 2110 and IPMX to their own products. So today I'm going to start by talking about the evolution of NMOS for 2110 and IPMX. It'll be more of a high-level overview. My goal is to help you understand what NMOS actually is and how it works. So a quick overview of what I'll be talking about in the next 20 minutes is what exactly is NMOS. I'll give an overview of all of the different NMOS specifications. I'll talk about some legacy broadcast applications of how NMOS is used in a broadcast facility for production. I'm also going to talk about the evolution of NMOS. How are we using NMOS for Pro AV and IPMX? And then I'll go on and talk about security, how you can test NMOS, and how you can try it yourself. So what is NMOS? NMOS is the Networked Media Open Specification. It was developed by AMWA, the Advanced Media Workflow Association. And this is an open specification. You can go to the AMWA website, you can see exactly how the specifications work and how to incorporate it into your own product. And what NMOS does is it enables the true interoperability between different vendors' products in a 2110 or IPMX environment. So this gives you the true plug-and-play functionality and push-button simplicity of any AV over IP routing. So as I said, there's many different NMOS specifications. It can look a little bit like alphabet soup. We have these IS specifications. We have BCPs, which stands for Best Common Practices. It's a lot of different numbers and names, but I'm going to try to help you understand what they all do and what they mean. So there's a new initiative within AMWA to try to make it easier to understand. And what AMWA has done is sort of split up the specifications between NMOS Connect and NMOS Control. So some of these specifications are more for the connection of these NMOS devices, things like resource management, connection management, and then eventually we're moving into NMOS Control, which is things like actually controlling devices. So within NMOS Connect, which is what I will be mainly speaking about today, is resource management. We have the common ISO4, which is the registration and discovery. And there's a couple of BCPs that have built upon that and added things like labeling. How can we organize our NMOS devices with labels and grouping and some tags and things. And then there's also some automated ways to make it easier for your NMOS devices to connect to the network. You may have heard of connection management, ISO5. I have a couple slides on this coming up. And we've built upon that with audio channel mapping, where you can change your audio streams and embed them into an SDI stream or keep it into IP and have a map of inputs and outputs. And finally, there's a lot of different supported functionality and codecs, things like JPEG-XS. We're adding features to be able to have JPEG-XS, H.264, H.265, MPEG-TS is a new one, and NDI as well. So why should we care about this whole NMOS thing? Well, in the early days of IP, you had to have a system integrator, you plug in all your devices to the network, but you had to sit there behind your computer and type in all the IP addresses, and it was very time-consuming, costly, and error-prone. You have to type in all these manual IP addresses for every device on the network. So we said, there must be an easier way, and that easier way is through NMOS, and that gives us the plug-and-play functionality. Plug-and-play is fun. It's much better than plug-and-pray, as we said before. Also, most new broadcast facilities are specifying NMOS, so they say, if you're making an IP product, a 2110 or an IPMX product, we want you to speak NMOS because there's a lot of great features that come with it. And most all control system providers have fully embraced NMOS. Almost all of the broadcast controllers, we'll say maybe 99%, are embracing NMOS fully. So we're trying to get that remaining 1% to jump on board and use NMOS as well. So in addition, there's this article from the EBU back in 2020, the early days of NMOS, and they saw the capabilities of NMOS and wanted to support it. So they had this article, this minimum user requirements to build and manage an IP-based facility. And they say, you shall use NMOS ISO 4, you shall use NMOS ISO 5. We know this is something we want in our IP facilities, so if you're building products, you should implement these features. So as I mentioned earlier, there's kind of two separate groups of NMOS. So there's what we're calling NMOS Connect, and there's NMOS Control. For my presentation, I'll be mainly focusing on this NMOS Connect portion. And first, I'll start with some legacy broadcast applications. How are we using NMOS in broadcast facilities? And then I'll talk about Pro AV in the end of the feature. So how does this NMOS thing work? Here's a handy diagram that shows a little bit about ISO 4 and ISO 5. So in a broadcast facility, you have all these different devices. It could be cameras, it could be gateways, maybe you have a monitor as well. So you have all these NMOS-enabled devices that automatically register to this RDS, this registry. It's a registration and discovery service. They automatically register, and then this control panel, it could be just a simple, push-button control panel to switch sources. That gets a list of all your devices from the RDS. So it queries the RDS, and it gets a list of all the devices that are connected to your IP network. And then when the user wants to switch sources and they press a button on the control panel, what that actually does is it queries the registry and it commands the receiver to join a new stream. It uses this IGMP join to join a new stream to switch sources, and then it commands the receiver to leave the previous source. And then that does the seamless switching. That's the source destination take that everyone's used to. So I talked a little bit about ISO 4 in the previous diagram, but what exactly is ISO 4? Well, ISO 4 does the registration and discovery portion, and in simple terms, you have all these devices on your IP network, and you have your NMOS controller. In this case, it could be a Conduct IP or any other NMOS controller, and that just announces to the entire IP network, hey, I'm an NMOS controller. Is anyone out there? Are there any NMOS devices on the network? And then automatically, any NMOS devices on the network will respond and say, yes, I'm a gateway or I'm a camera. Let me register. So it automatically registers to this RDS using MDNS or DNS-SD. So ISO 5 is kind of the part that goes hand in hand with ISO 4. This provides the connection management part. This is what gives us the seamless switching. So ISO 5 enables that switching through what we call activations. And the activations can be either immediate, relative, or it can be absolute. So you could say, I want to do that switch now. You press the button your source destination take. I want to make that switch now. Or you can have it make the switch in 5 seconds, or you can have it make the switch at a set time. So if you want to look into some of the NMOS parameters, it's just a set of APIs. It's all in JSON, which is easy to read. And the way you access that is you just go onto a normal web browser like Chrome or Safari or something. You navigate to the IP address of your NMOS node and then /x-nmos. And there's a couple of different API endpoints where you can see the parameters of your sender, receiver, different devices on the network. So as you know, there's a lot of parameters involved in configuring an IP facility, things like different API versions. You have PTP, domain and announce intervals, different system IDs, lots of different protocols. Wouldn't it be nice if there was an easier way to automate these? Because we want that plug and play functionality. We want to just plug something in and have it work quickly and easily. And that's exactly what ISO 9 does. So this is an NMOS specification for system parameters. And what ISO 9 does is it provides an automated configuration of the media nodes. So if you have an NMOS device, you plug it in, and then all the devices on the network know all of the startup parameters in that facility. The way ISO 9 actually works is it's a server. It could be a little like Intel NUC here. It's a little DNS SD server. It has all of the parameters already programmed in there. And then when you plug in any NMOS nodes or devices, they read all the configuration info on startup and automatically have all of the correct configuration information. So when you have so many NMOS devices, you could have things like a camera, a gateway or something, and within a 2110 environment, remember every flow is sent as a separate stream. So you have your video flow, your audio flow, and your auxiliary flow. But we want to make sure that these, if you want to route them together, we want a way to tag them and say, okay, these all belong within the same flow. And we can use this best common practice for grouping. It's a way to say, okay, say I have a gateway here, and there's video, audio, and auxiliary flowing through it, but we want to make sure that all those flows are sent together. We can use this best common practice of grouping. It's actually called a group hint, and it's almost like a hashtag, and you say, okay, this is all together. I want these all to be combined with this playout master flow. So you're combining multiple video or audio or auxiliary flows all to one and making sure that they stay together. So NMOS has further built upon that idea. So the last one was called group hints. That's natural grouping of resources. We also have a way to have more tags and things. So this is especially relevant in these days where there's more software-defined processing. Maybe you have a multi-function box that's in a server room somewhere, and it can either be a format converter or a multiviewer or a keyer. We want to actually see what that NMOS node is doing. So there's a standardized way within NMOS to say exactly what is this device doing. It says you should say what the manufacturer is, what the product name is, an instance identifier, which is an easy way to see, okay, where is that physical product located? If it's in a server room, maybe you'll say, all right, that one is on floor 2, rack 1, position 5. This is the device that we're talking about. And then in my example of the software-defined processing, which is more and more relevant these days, that device could run any number of apps. So it's important to see what is the current function of that device. And in this example, it could be a format converter, or it could be a multiviewer or something like that. So there's also another specification for audio mapping. Again, because in 2110, the audio, video, and ancillary is all sent as separate streams, we can actually use that to our advantage. And if we want to combine multiple audio output channels and embed them into an SDI stream in a gateway or something, we can actually make a map of different audio input channels and map them to a specific audio output channel. And what that looks like is, here in this example, we have maybe 2 different audio streams that have 8 channels each. So stream 1 is channels 0 through 7, stream 2 is channels 0 through 7. And then we have our 16-channel audio output. You can have a simple matrix like this and just choose which input audio channels, that you want to route to your audio output channels. And you can have any combination of input channels mapped specifically to your combined audio output channel, either in SDI or IP. NMOS also supports what we call event and tally. This is ISO 7. And this is a way that we can send GPIO over IP signals using NMOS. This leverages ISO 5 for the connection management. And this is just an easier way to send something like a tally signal or a tally light, or maybe you want some dynamic text. And the way this works is you have a sender, maybe in this case it's a production switcher, and you want to light up a tally light on a camera. We can use ISO 5, and either using WebSocket or MQTT, there's a way to actually send that message to the receiver and say, okay, please light up that tally light, or display this dynamic UMD. So that's sort of what NMOS is currently used for in legacy broadcast applications, but we're also using NMOS for Pro AV, and now that IPMX is gaining a lot of traction, we've developed NMOS to support IPMX as well. So NMOS has evolved a lot for Pro AV. So how did we make NMOS work for Pro AV? Well, we have a couple of BCPs. It's called NMOS for JPEG XS, because again, Pro AV, they like compressed video, whereas broadcast is more uncompressed. So we have some specifications for, it's referenced by VSF TR10-8, which is NMOS for IPMX. It also refers to other VSF specs like TR08 for transport of JPEG XS in 2110. So this also leverages ISO 4 and ISO 5. It leverages the grouping that we talked about earlier. And what this does is it really just specifies any updates in a Pro AV environment to something called a session description protocol. This is an SDP file, and it uses this media type, this video/JXSV. So you know that your device is using JPEG XS, which is common in Pro AV and IPMX installations. So there's also a big new development. This is probably the biggest new thing for NMOS in the Pro AV and IPMX side of things. It's IS11 for stream compatibility management. And what this is essentially it's EDID over IP. So if you're familiar with how HDMI works and you have your laptop or something and you plug it into a monitor, that monitor actually tells your laptop, hey, I can do HD or I can only do 4K, so it tells your laptop exactly what resolution it supports. And this is what IS11 does. It does the same EDID over IP. So a state of a sender can be tuned by the receiver to make sure that it's compatible with that receiver. So I gave a little example in the HDMI world, but it also applies to IP. If you have, say, an IPMX device like a gateway or something, and the monitor only supports HD, it'll tell that device, okay, please only send me HD. So I have an example here, a more visual example of how this NMOS IS11 works. This is a very simple IPMX Pro AV application here. You have a PC, maybe a gateway, so it's HDMI to IP, over the IP network to another gateway, and over to a monitor. So everything is connected through the NMOS controller, and we want to leverage this EDID. So what happens is the monitor tells the gateway, okay, here's the EDID, here's my capabilities, and that flows all the way through the network and back to the PC. And there's different constraints, different monitors, different gateways, things can have different constraints. So in this example, maybe your sender can only send 1080p, 4K, and it can do JPEG XS and HDCP. Well, what can your receiver do? The receiver maybe can't do 1080, but it could do 720. But oh, it also does 4K. And oh, it also does JPEG XS and HDCP. So what this IS11 does is it finds that sort of the least common denominator, that commonality between the senders and receivers to make sure that they're speaking the same language. So what it actually does is it patches the EDID and says, okay, here's my active constraints, here's the commonalities between the sender and the receiver. Please make it 4K, please have JPEG XS and HDCP to make sure that everything is cohesive. And this actually tells the broadcast controller to send a new EDID to the PC to make sure that it's sending the correct signal. So what about security? This all sounds great, but we want to make sure it's secure. Well, there's a lot of different specifications in place. We use TLS and HTTPS, common IP security things. We also have authorization through some best common practices. We use certificates using TLS. And there's also an IS spec called IS10 for authorization. And this just makes sure that users are authorized to change an NMOS system. It uses JSON web tokens and OAuth 2.0, but what this really means is it just makes sure that users are authorized to change the system and maybe has a login screen, something like that. An example of how this security actually works is you have your broadcast controller, an IP source, and a destination. We use an authorization server and then send the authorization request to the server. It responds with a JSON web token, and then the controller will then send that activation with the web token to the source. The source will have to verify the web token is valid using a public key provided by the authorization server. And then that source will start transmitting its essence flow. Meanwhile, the broadcast controller also sends the activation to the destination with its JSON web token. That verifies with the public key also, make sure it matches. And then if everything looks okay, then it says, okay, you're authorized to receive that stream. So what if you want to test NMOS? Say you're a system integrator or you're an equipment manufacturer and you want to make sure that NMOS is working properly according to the specifications defined by AMWA and supported by the industry. Well, we made it easy. There's a GitHub right here. You can go to GitHub, to the AMWA page, and look up all these automated tests to make sure that an NMOS device is functioning as specified. And then what if you want to try NMOS? Say you set up a little demo or you're in a broadcast facility and you want to actually try NMOS for yourself. There's a free way to do that, and that's through the Riedel NMOS Explorer. You can go to the Riedel website, download this software, and this is a free and easy way to see all of your NMOS-enabled IP devices on the network. You have your nodes, devices, senders, and receivers. And there's also products you can buy, broadcast controllers that do the same functionality, that have better user interfaces. We like this one. It's a Matrox Conduct IP. This is a full-featured broadcast controller, and it gives you kind of the more familiar cross-point switch you get here with your senders on the top. These are all your IP senders. These are all your IP receivers. And with the click of a button, you can actually do that switching using ISO 5 and ISO 8 and everything. And it's a familiar way to do that push button switching. So as now the boat's turning around, a couple conclusions. NMOS ISO 4 and 5 are stable, they're mature, and they're in almost all new 2110 products. The control systems have been greatly improved thanks to spec clarifications and lots of interop testing. There's many interop events and testing events through the JTNM and AMWA and the VSF to make sure that everything is fully, truly interoperable and working to specification. Some of the new features I talked about, things like ISO 8 and ISO 9 for system parameters, make it really easy to get your NMOS devices automatically registered to the network. And this far surpasses the level of control that we had back in the SDI days. The security is a very important addition. We want to make sure users are authorized to change anything in an IP facility. And finally, there's lots of work still being done and constantly being done to expand NMOS for IPMX and Pro AV. Things like the IS-11 we talked about. And new exciting developments are on the NMOS control side, where we're actually trying to be able to fully control devices using NMOS through NMOS control. All right, thank you. If you'd like to learn more about NMOS, or if you would like to see how Nextera Video can help you add 2110 or NMOS or IPMX to your own products, please see our live demo. We're in Hall 10 at booth C13. Thank you.